Algebra, Chapter 4, Section 5, Equations, Inequalities, and Applications involving root functions. To solve an equation involving roots such as the square root of 11 minus x equals 1, in which the variable appears in a radicand, we're going to apply the following property. The power property says that if p and q are algebraic expressions, then every solution of the equation p equals q is also a solution of the equation p to the n equals q to the n for any positive integer n. In other words, if you need to, you can raise both sides of an equation to the same power, and the solutions for the original equation will be solutions for your new equation. However, it doesn't say that these are equivalent. The new equation, after you've raised both sides to a power, may actually have more solutions than the original. What that means is that we need to check all solutions in the original equation in order to eliminate any extraneous solutions. If you've forgotten what that means, extraneous solutions are solutions that you arrive at when you solve an equation properly, but the solutions themselves don't work in the original. We really have to be careful of these with equations such as the ones we're talking about here with the root functions, and also with rational functions. So, to solve an equation involving a root function, the first thing we're going to do is isolate a term involving a root on one side of the equation. It may be that you have more terms that involve roots. You need to get one of them isolated. Then you're going to raise both sides of the equation to a power that will eliminate the radical or rational exponent. In other words, if it's a square root, you're going to square both sides. Next, you're going to solve the resulting equation. Now, if you still have a root in the equation, then you're going to need to go back and repeat steps 1 and 2. And then finally, check each proposed solution in the original equation, again, to make sure you don't have any extraneous solutions. So, let's try that problem that we had up there a minute ago. See if you can solve the square root of 11 minus x equals 1. Remember, we want to isolate the root first. Pause the recording, give this a try, and resume the recording to check your answer. So the first thing we do is we add x to both sides. That's isolating the radical. Then to get rid of the square root, we square both sides. Now remember, 1 plus x squared is not 1 plus x squared. It is 1 plus 2x plus x squared. You must FOIL it out. Then what we're going to do is, well, we've got a quadratic. We have a highest power of x squared, so we're going to make it look like a quadratic equation. We get everything on one side and 0 on the other, which is called standard form. And then we factor and we solve, and we end up with x equals -5 or x equals 2. Now, as we said before, you need to check both of these in the original equation. If we put in -5, we get the square root of 16 plus 5 equals 1. Well, the square root of 16 is 4, and 4 plus 5 is not 1. So, -5 doesn't actually work in the original equation. Now try 2. 11 minus 2 equals 1. So we have the square root of 9 minus 2. The square root of 9 is 3, and 3 minus 2 is indeed 1. So true. So 2 is the only solution. We graphed y1 equals the square root of 11 minus x, and y2 is 1 plus x. And then we found the intersection, and you'll notice they only cross at one point, and that is at x equals 2. Now we're going to solve an equation involving a rational exponent. Now listen though, 1/2, power of 1/2 is the square root. So what this problem really is, it's the square root of 5 minus 5x plus x equals 1. So you're going to use the same procedure we just used. Pause the recording, give this a try, and resume the recording to check your answer. As we said before, it's really going to be the same procedure. We subtract the x from both sides, so we have 5 minus 5x to the 1/2 equals 1 minus x. And again, 1/2 is a square root, so we're going to square both sides. And using our properties of exponents, when you raise a power to a power, you multiply them, so the 1/2 times 2 becomes 1, and you just have 5 minus 5x. On the right-hand side, you need to FOIL out 1 minus x squared, which gives you 1 minus 2x plus x squared. Now you're going to write that in standard form. So you have x squared plus 3x minus 4 equals 0. Factor this, and then set each factor equal to 0 and solve. And you get -4 or 1. Again, check both of these in the original equation and see if they work. And you can see here when we check both of them, we actually find that both do work, which is great. So we actually have two answers for this problem. It's -4 and 1. Graphically, what we did here was they actually subtracted the two from each other and looked for where it crossed the x-axis. Again, you could graph y1 and y2 and see where they intersect. Either way will work, and you can confirm that both answers do indeed work. Now we're going to solve one that involves a cube root. Same procedure. Give the recording a pause, give it a try, and resume the recording to check your answer. And as you see here, we again follow the same procedure. This is a cube root, so we're going to raise both sides to the third power. That gives us x squared plus 3x equals 5. We set that equal to 0 and discover that we can't factor that, so we resort to the quadratic formula. When we do that, we get -3 plus or minus the square root of 29 over 2. And you could check that in the problem and show that both of those. Now, this one is a little bit different because we have two radicals. Remember that what you need to do is you need to isolate one of them. So one of those radicals needs to go to the other side of the equation. Then you're going to follow the procedures that we outlined before. Now with this one, you're going to end up with a radical staying in the equation and having to do the process again. We have done these before, at least I know that Algebra 3 has done them. Pretty sure we did them in Algebra 2 as well. So pause the recording, see if you can do this, and then resume the recording to see how you did. So what we did was we moved the x squared to x plus 1 over, and then we square both sides. Now again, on the left-hand side, that just cancels the square root, but on the right, we need to FOIL that out. And when you FOIL that out, you get 1 plus 2 times the square root of x plus 1 plus x plus 1. And then what we're going to do is work on isolating the radical again. So we're going to subtract the x's from both sides. We're going to subtract the 1 from both sides. They are leaving the 2 in front. Now you can actually divide that if you want to, or you can leave it there. And then we're going to square both sides. And when we do that, don't forget that that 2 is going to become 4. And don't forget that on the left-hand side, x plus 1 must be FOILed out. So we have x squared plus 2x plus 1 equals 4 times x plus 1. You're going to distribute that, and then you're going to write it in standard form. So you get x squared minus 2x minus 3 equals 0. Factor x minus 3 times x plus 1, and that gives you x equals -1 or 3. Check these in the original equation to show that both of them are solutions. Now we're going to do an inequality. And you've done a lot of these. See if you can think about how this is going to work. Pause the recording while you do that and resume the recording to see how you did. You may have recognized this problem. We actually already solved it earlier, at least the equation. And we got -3 plus square root of 29 over 2 and -3 minus the square root of 29 over 2. Now, if you look at it graphically, we're going to let y be the cube root of x squared plus 3x minus the cube root of 5, and we're going to graph that. And then what we're going to do is see where we're using the x-intercept method, and the zeros are going to be what we found earlier. -3 plus the square root of 29 and over 2, and -3 minus the square root of 29 over 2. So we know the zeros. The question is, where is this thing going to be less than 0? And if you look at the graph, you can see that the graph dips below the x-axis between the two solutions. So you can see that the solution is going to be the interval between -3 minus the square root of 29 over 2 and -3 plus the square root of 29 over 2. Now try this one with negative exponents. It may help to rewrite it as fractions. Give it a try, work the problem out, see if you can do it, and resume the recording to check your answer. Now, as I said, you can rewrite this as fractions. The book didn't quite take this approach. If you rewrite it as fractions, you would have 15 over x squared minus 19 over x plus 6 equals 0. You would then multiply everything by x squared to get rid of the denominator. And in doing that, you would end up with what ultimately the book ends up with, which is 15 minus 19x plus 6x squared. And what they did is they said, well, if I multiply both sides by x squared, then that's going to take care of the negative powers. Because remember, when you multiply two variables together, you add their powers. So 15x squared times negative x squared is going to be just 15, or 15x to the 0, which is 15. And you can do the same for the 19x squared times x to the minus 1 is just going to be 19x to the first. And then the 6 is going to get an x squared. Either way, you're going to end up with the same equation. Rewrite it into standard form, factor it, and you get that x is 3/2 or x is 5/3. Check the solutions into the original equation and show that they work, and your solutions are 3/2 and 5/3. Now we have one using fractional exponents. All right, think about this for a moment. What would be a really good way to get rid of those fractional exponents? Pause the recording and give this a try, and resume the recording and see how you did. All right, what they did here was they kind of rewrote it. We've done this before, a u substitution. They said, you know what? This is almost like 2x squared plus 5x minus 3. If we didn't have that 1/3 there, the 3 on the bottom, it would be. So they kind of treated it that way. In fact, they said, all right, you know what? X to the 1/3 is going to be replaced with the letter u. And they put in, so that gave us 2u squared plus 5u minus 3 equals 0. And then when you factor it, you get 2u minus 1 times u plus 3 equals 0. Solving for u, we get 1/2 or negative 3. Now, remember, the original problem, we didn't have a u, we had an x. So now we have to go back and say, okay, x to the 1/3 is 1/2, or x to the 1/3 is negative 3. Then we will cube both sides, and we get that x is 1/8, or x is negative 27. Both of these work in the original problem. Okay, now we're going to do an application problem. A company wants to run a utility cable from point A on the shore to an installation at point B on the island. And you can see the diagram. The island is 6 miles from the shore. So from B to point C, which is straight, shortest distance to shore, is 6 miles. It costs $400 per mile to run the cable on land and $500 per mile underwater. Assume that the cable has to start at A. It's going to run along the shoreline, and then it's going to angle and run under the water. Okay, X is going to be the distance from C to where the cable leaves shore and goes under the water, and you can see that on the diagram. That means from that point to A will be 9 minus X, because the distance from C to A is a total of 9. So if you're looking at the diagram, you can see that X is the part from C to where the cable is going to run under the water, and then from that point to A has to be 9 minus X, because the two together have to total 9 miles. And this K here is going to represent the amount of cable that's under the water. Okay, so, and we've got these variables here because we're going to kind of play around with the numbers and the costs involved in this. Okay, so you might want to make a rough sketch of this as we go through and look at the different questions that are involved. So you might want to pause for a second, make kind of a rough sketch of this, and then we'll move on. Okay, so what we're going to do is we're going to figure out the possible values of X in the problem. We're going to express the cost of laying the cable as a function of X. We're going to find the total cost if 3 miles of cable are on land. And we're going to find the point at which the line should begin to angle in order to have the least cost, and what would that cost be. All right. Now, if you're feeling very adventurous, pause the recording and see how many of these you can get through, and then resume to see how you did. Okay, A isn't too hard. We know that X has to be greater than 0 and it has to be less than or equal to 9, because the distance from A to C, which is the closest point on shore to the island, is 9 miles. And it doesn't make sense to have x go below 0. So x must be between 0 and 9, including 9, but not 0. Now, K is going to be the length of the cable underwater. We mentioned that before. So we're going to use the Pythagorean theorem, because we've got a right triangle there, and say that K squared has to be 6 squared plus x squared. So K is going to be the square root of 36 plus x squared. We know it has to be greater than 0. The cost of running cable is the price times the number of miles. So if C is the total cost of laying the cable across land and underwater, then, remember it was $400 for land, $500 for water. It's going to be 400 times 9 minus x, that's the distance it'll go along the shore, plus 500 times what we just found, the square root of 36 plus x squared, and that's the distance of K. So, part C, if 3 miles of cable are on land, then 3 equals 9 minus x, which means x must be 6. So we just put in 6 to the function we found in B. So if you got B, this won't be too hard. Just put in 6 for x, and you get $5,442.64. We're going to use the graphing calculator, and the function that we found, the cost function, is going to be our y. And just graph that in. You can see the equation there, 400 times 9 minus x plus 500 times the square root of 36 plus x squared. You only want to graph it. Your x minimum should be 0, your x max should be 9. Now your y, the minimum y should be 0. We know that 3 miles of cable was over $5,000, so you're going to want your y max to be pretty high. The window here uses 6,500. But we're really interested in finding the minimum value, so I guess you don't need to get too high with the y value. So you're going to find the minimum, and that occurs when x is 8. So 9 minus x, 1 mile should be along land, and 6.08 miles underwater, and that cost is going to be $5,400. The rest of this is extra practice. Pause the recording and give them a try, and then resume the recording to check your answer. Proceed like this through the rest of the recording.